Alright guys, in this video we're going to be talking about the nomenclature of alkenes and alkynes. That means we're going to be looking at the hydrocarbons that's going to have the double bonds and triple bonds in there, and sometimes you may have both of them in the same molecule, in the same structure, and how would you name the compound in that particular case. So let's start out with the simple rules here, and you must follow these rules in order to be better in naming the compounds. So the first rule says you must pick your parent chain, and in this particular case your parent chain must have the double bond or the triple bond included. And sometimes your chain may get shorter when you include the double bond or triple bond because the other end could be longer, but that's completely okay if it gets shorter, but you must have the double bond and the triple bond included. Now if we look at these three examples, you may want to pause your video and figure out what's going to be the longest chain in those three examples. So let's suppose you did that, and I have, for the first one, my longest chain that includes the double bond is going to be going from the double bond and going to the bottom to the left here, and that would have 1, 2, 3, 4, 5 carbons in there, so that's going to be 5 carbons long. And obviously if I exclude the double bond and just go from left to right, it's going to be a 6 carbon, but that does not have the double bond in that case, so you can't really pick that particular one. Now for the second example, it seems fairly simple. The longest chain is going to be going from left to right, and the number of carbons I got in there is 1, 2, 3, 4, 5, 6 carbons in there. And on this third one, the longest chain is going to be coming from the triple bond going to the left, and then from there you can either go to the top or to the bottom, because the top you have 3 carbons and on the bottom you also have 3 carbons, so it really doesn't matter. And in this case the number of carbons is going to be 1, 2, 3, 4, 5, 6 carbons in there as well. So that's the first step going to be you figure out your longest chain that includes the double or triple bond. Now the second factor you want to put it in there is start numbering the chain so that your double bond and triple bond gets the lowest number possible. Now let's focus on this first one. Since I want to make sure the double bond gets the lowest number possible and it gets the priority over the substituents, like whether you have those halogens as your substituents or you got these alkyl groups as your substituents, your double bond or triple bond gets priority over that. So in the first case, I would have this to be called 1, this is going to be 2, that's going to be 3, and that's going to be 4, and that's going to be 5. Okay, so then I can clearly see I got a substituent on the second carbon, and that one is going to be the ethyl. So you want to make sure you keep track of your substituents as well. On this third one, on this second molecule, the longest, we already got the longest chain going from left to right, and when it comes to numbering, even if I number from the left side, your methyl is going to get number 2, but remember your double bond gets the priority, so you must count it from the right side. So it's going to be 1, 2, 3, 4, 5, 6 right there. And then I got a methyl group on the third carbon, and then I got a methyl group on the 5th carbon, so you want to make sure you keep track of those as well. And then on this third one, I would count it 1, 2, so wherever you have the triple bond being finished, that's where your carbon is going to be located. And then this is going to be 3, 4, 5, and 6, and we clearly see on carbon number 3 we got this propyl group. And then on this next one, we got 2 double bonds, so you got to be careful with that as well. If I count it from the right side, or let's say if I count it from the left side, then I get the first double bond gets number 2 carbon, 3, 4, 5, 6, 7. And if I count it from the right side, then your first double bond is going to get position 3. So you want to make sure it gets to the lower position, so you start it from the left side. So that's how you're going to be numbering those, and I can go ahead and actually name those since we already know everything about substituents and your side groups in there. So the first one, since I got a ethyl group on the second carbon, it's going to be called 2-ethyl. And since we have 5 carbons in the main chain, it's going to be pent. And the double bond is at the first position, so you could very well call it pent 1-ene. But remember, if the double bond or triple bond is at the first position, you really don't have to specify the position of the double bond. So you can just call it pentene. So always keep in mind, if it's an alkene, your name is going to end up with ene. And if it's an alkyne, your name is going to end up with yne, Y-N-E. All right, so whether writing it like that or writing 2-ethyl pent 1-ene is the same thing. Now, when I look at this second one, I got 2 methyls on the 3 and 5, so it's going to be 3,5-dimethyl. And the suffix is going to be hex, and since it's an alkene, it's going to be an hexene. Again, your double bond is at the first position, so you really don't have to specify the position of the double bond. And then when I look at this third one, now we got alkyne, and on the third position we got this propyl group, so it's going to be 3-propyl, and since we got 6 carbons, it's going to be hexyne. So remember, it's going to end with Y-N-E because it's an alkyne. Now, if you have 2 double bonds, like in this case, then it would end up with diene. So you have to use prefix di for the 2 double bonds, and you have to specify their locations since the double bond is not at the first position. So we got 7 carbons in the main chain, so it's going to be hept, but then I want to specify the position of the double bond, so it's going to be 2, 4, and you always specify the position where your double bond is going to be starting. So you don't really call it 2, 3 or 4, 5. You just call it 2 because that's where your double bond is starting, and you call it 4 because that's where your double bond is starting. So it's 2, 4, and you can call that heptadiene. So you use di because there's 2 double bonds in there. If you have 3 double bonds, then you would try. If you have 4 double bonds, you will use tetra. Okay, well, what if you have both the double bond and the triple bond present in the molecule? So it gets a little bit complicated if you have both. And when it comes to numbering in that case, you just pick either side and see which one gets the lower number of carbons. For example, whether it's a double bond or a triple bond, it doesn't really matter. Whichever side gets the lowest number possible, that's where you're going to be start counting from. So if I count this from the left side, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then if I do count it from, let's say, from the right side, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So when I'm counting from the left side, your triple bond comes on to the second position, and when I'm counting from the right side, your double bond gets onto the third position. So they don't really get priority one over the other. It's more or less who comes first. So since the triple bond comes first, you want to start counting from the left side. Okay. However, your triple bond, which is going to end with yne, that's going to be placed at the very end, and that's always going to be the case. So in this, I have a methyl at the 8th position, so I can go ahead and erase the wrong way of counting so that we can just look at only one of them. So I have 8 methyl, and then I got a double bond at the 6th position, so it's going to be 6. For the 9, it's going to be non-ene, so it's going to be non-ene. So it ends with en. Don't put e at the end because there is going to be a Y-N-E. And then you want to specify the position of your triple bond, which is going to be at the 2nd position, so it's going to be Y-N-E. So it's going to be 8 methyl, 6 non-ene. So you put 6 because of the position of the double bond, and then 2 Y-N-E. Well, what if there is a tie? Like it doesn't really make a difference whether you count from one side or the other side. Your double bond and triple bond gets the same position or the same number. In that case, your double bond gets the priority. So in this case, whether you count it from the left or to the right, your triple bond gets the first position, your double bond gets the first position. So in that case, I want to have your double bond gets the priority. So it's an 8-carbon chain. All right, so it's going to be octene. So I don't really have to specify the position of the double bond because it's at the first carbon. And then this, you do want to specify the position of your alkyne now. It's at the 7th carbon, so it's going to be 7YNE. Okay, well, sometimes you may get into a complicated problem where you have multiple possibilities of the longest chain, and if that's the case, you want to follow this order. So if you have multiple possibilities, go with the chain. Obviously, you want to make sure you get the maximum double bond and triple bond. Go with the chain that has max number of carbons, and if that doesn't help, then go with the chain that has max double bonds, and that usually helps. Okay, so let's look at some of these examples here. Okay, so you may want to pause the session here and do some of these examples on your own and see if it matches with my answer here. So when I'm looking at this first one, I would count it from the double bond. So it's going to be 1, 2, 3, 4. So that's one way of counting it. But if I counted the other way, what difference that's going to make? It's going to be 1, 2, 3, 4. So you're getting the same number of carbons going either way, and technically when that's the case, you want to make sure you go with the most number of substituents. So like if I go with the yellow numbering, then you get only one substituent at the second carbon, but if you go with this pink numbering, then you get one substituent at the second carbon and one substituent at the third carbon. And the rule says you want to make sure you get maximum number of substituents. Okay, so this is going to be 2-ethyl and then 3-methyl. And since it's a 4-carbon chain, for the parent chain, it's going to be butene. I don't really have to specify the position of double bond because it's at the first location. Okay, let's look at the second one. Before we look at the second one, I do want to look at the third one first. The third one seems simple. You want to make sure, since it's a ring, you want to make sure you get your double bond included in both of the carbons, and both of those carbons gets the lowest number possible. So I don't really want to count it this way. If I count it this way, I get 1, 2, 3, 4, 5. Then you get those substituents where we have those 2 methyls as carbon number 5s. But what if I counted this way, where I start with 1 here, 2 here, 3, 4, 5. So that means your substituents are going to be at carbon number 3 in that case. So I have 2 methyls, so it's a 3,3-dimethyl, and it's going to be cyclohexene. So I don't want to specify the position, cyclopentene rather, because it's a 5 carbons. It's going to be cyclopentene. So I don't want to specify the position of the double bond because we counted that as the first position. And you don't want to count the 2 methyls as your first location because your double bond gets the priority, and your double bond must have the lowest number over the substituents. Now, what about this second, this middle one I missed here? So in the middle one, it actually, if I started from here, that's going to be 1, 2, and 3. Turns out your substituent, which is at the second position, could actually get number 1 if you start the other way around. So I get 4 here and 5 here. But if I count it the other way around, it's going to be 1 here, 2 here, 3 here, 4 here, and 5 here. So then whenever there is a tie between the double bonds, you want to count from the side that gives the substituent the lowest number. So whether you go with the blue with the yellow numbering or the pink numbering, your double bond is indeed getting number 1 in both cases. But then when you go with the pink, your first substituent is going to be at the first carbon, but when you go with the yellow, your first substituent is going to be at the second carbon. So as a result, your pink numbering is going to be a better way or correct way of numbering this cyclopentene. So I got 3 methyl groups, 1 on the first carbon and 2 on the fifth carbon. So it's going to be 1, 5, 5 trimethyl, and that's going to be pentene. Okay, what about something like these two? So I got 1, 2, 3, 4 here, and since the double bond is in the second position, it's going to be but-2-ene. You can write it like this, or you can also write it 2-butene. It doesn't really matter. Now, what about this second one? It's going to be 1, 2, 3, 4, and it seems like it's going to be the same name. It's going to be but-2-ene or 2-butene. But what's really the difference between those two? I can't really go from this first 2-butene to the second 2-butene because there is a restricted motion, a rotation around the double bond. And as a result, if you recall, these are going to be called your geometric isomers. So where your first one is going to be the trans. So you want to make sure you write down trans in front of it. And your second one is going to be the cis. Okay, and that's because you have both of the in the first one, you can see the 2 hydrogens are on the opposite side, so you have 2 small groups on the opposite side. 2 big groups are at the first carbon and the fourth carbon. Those 2 methyl groups are on the opposite side. So when you have the big groups are on the opposite side, it becomes trans, and when you have the big groups on the same side, it becomes a cis. And you can say the same thing with the smaller group in that reference. If you have smaller groups on the different side or on the opposite side, it's going to be the trans. And if you have the smaller group on the same side, like in this case, you got both of those hydrogens to be pointed onto the same side around the double bond, that makes it a cis. Okay, what about something like this? I got, let's say, 1, 2, 3, 4, and 5. So there is a fluorine on the second carbon and there is a chlorine on the third carbon. Now, whenever you have actually different groups attached around the double bond, it's not that easy to figure out whether it's going to be a cis or trans. Then you look at your, let's see, if I change the color here, then you look at the priorities, and the priorities usually comes with the atomic numbers. So onto this pink carbon, I got the fluorine and the CH3 attached. Now the fluorine, that's the first atom attached to that carbon. The fluorine has an atomic number of 9. And then the carbon that's attached to that double bonded carbon is going to have atomic number of 6. So since fluorine has a higher atomic number than carbon, it gets the priority. So I'm going to go ahead and write down, let's say, 1 for the fluorine and 2 for the methyl group. Okay, what about the other side? So let's change the color there. Let me change, oops. So when I change the, when I look at this other carbon, I got the chlorine and I got the carbon here. So there is 2 hydrogens. So chlorine is going to have an atomic number of 17. And then your carbon is going to have atomic number of 6. So since they are, the chlorine is going to win over the carbon, your chlorine is going to get number 1, and your carbon or the carbon side or that whole group is going to get number 2. And if there's a tie, then you move on until you get until you figure out who is going to get the bigger priority, or until there is a difference in the atomic number. So now you can clearly see here how your 1 and 1s are opposite to one another and their 2s are opposite to one another. So since they are opposite to one another, it's actually going to be a trans. So when I name this, I'll say it's going to be 3 chloro, and then I have 2 fluoro, and I'm going to specify the position of double bond, which is second position, and it's going to be 5 carbons, so it's going to be a pentene. And since it's a trans, I would say trans in front of it. So the other name for the trans is E, so you may see this being written as E, and then you got 3 chloro. I can probably just copy that down actually. So the other name would be E, 3 chloro, 2 fluoro, 2 pentene there. Okay, so that's how you're going to be naming this. Let's look at this last example. And you may want to pause the session here and do this. Seems like your longest chain is just going to be going from left to right. I mean, obviously, if you come down at this point right there, you may get a longer chain, but then you excluding this double bond right there, which you don't want to happen. So I'll just take that out. So when I'm numbering this, I would have, now which way I'm going to start numbering from. So there is a tie between the triple bond and the double bond, and in that case the double bond is usually going to win. So you got 1, 2, 3, 4, 5, 6, and 7. So I got 2 substituents. I got an ethyl group on the 3rd carbon, and that I got a propyl group here. Okay, so your ethyl comes first, so it's going to be 3 ethyl, and then it's going to be 2 propyl, and then you want to make sure you specify the positions of the double bond. So even if the numbering of the triple bond is later on in the chain, but your ion still comes at the very end when you have both alkene and alkyne present. So I want to say 1, 3, and it's going to be heptadiene. So heptadiene. So make sure you don't put E at the end of E and E, because the name is not finished. And then you want to specify the position of the triple bond. So that's going to be 6. Let me just copy this down here. Okay, so it's going to be heptadiene, and then it's going to be 6 Y and E. So that's going to be the final name for this particular molecule here. All right, so this is how you guys going to be naming the alkenes and alkynes together. And